Well, good morning, Math 1, or good afternoon, or good evening. I guess whenever you are watching this video here. We have our very first distance learning Delta Math activity, and I'm here to walk you through it. I hope you're doing well. I hope this finds you well. I hope in the near future we can be a live class again. But for now, I guess we're sheltering in place. That's what I'm doing here in my second bedroom. And let's get this started. Most of you are on Delta Math, but if you are not, this is my teacher code. That's the only thing you should need to sign up. So give that a shot. And if you have any problems at all, give me an email. But the assignment, and let me pull that up for you here, should look like this. Wait, that ain't the assignment. That's The Office. Hey, who was watching The Office? Not everyone raise your hand at once. All right, let's do a new share. Let's go here. There we go. Okay, so that's what your screen should look like right now. So there's three, we got about 10 problems to do. I'll start with the first, says determining whether an integer satisfies an inequality. All right, so it's gonna have this inequality here, minus 2x is less than -4. And we've got a couple potential answers. One, let's see, 2 is -2, and then 5. Okay, let's come on back then. Okay, so this is the question. I want to know which one of these are potential answers, because inequalities have lots and lots of answers, because it's not about what value of x makes the two sides equal. It's what values of x make this side less than that side. So what we're going to do is on this, we're just going to plug in the values and see if the resulting situation is true. So that's what we'll do for these first two problems. So let's go get it. Let's go, I'm going to plug in 0. So let's watch this. I got -8 minus 2 times 0. And because I'm just kind of checking, and I wish I would have brought more colors. I'm actually a little embarrassed. I only have 2 colors in the house. If you know me, you know that's not acceptable. All right, so I'm going to put little question marks there because we're actually checking to see if it's true. Okay, so I'm going to subtract 2 times 0, but that is 0. So that means I'm going to have -8 less than -4. That is true because it's more negative. When you're comparing two negative numbers, if you're closer to 0, you're considered greater than a negative number that's further away from 0. So we know this one is all good. So let's get that one marked. All right, so we got to do -2, so I'll just erase that. All right, let's plug in -2 and see if it works. I am going to guess just randomly that it doesn't. I don't know why, just gonna guess. Who knows? Uh-oh, we'll see. Okay, so what do we have? We have -8. Now here's where, again, you're going to mess around with the negatives and the positives. I'm going to call that a takeaway sign. So I'm just going to bring down the takeaway sign. And I'm going to say take away 2 times -2, which is -4. So we know in math, as in life, if you take away negativity, you become more positive. So that's what's going to happen here. Instead of taking away -4, we're going to add 4. And so it actually is going to end up with -4. Now, -4 is not less than -4. It's the same as -4. So this one is not going to work. Holler. All right. So just got to check that 5, and we should be good. Now, I'm pretty sure 5's gonna work because I can tell that 5 is gonna keep all of this positive, and we're gonna end up taking away a positive, and thus we're gonna get even more negative than -8. But let's just do it the algebra. See what the algebra says. All right, here we go. -8 minus 2 times 5 All right, well, let's give it a shot. So I have -8, and again, I'm gonna think about this as a takeaway sign, so I'm gonna write it right there, minus. I got that as +2 times 5, which is +10. -8, take away 10. So anytime you take away positivity, you get more negative. It's true in life, it's true in mathematics. So what we got going here is -18 is less than -4, and that's true. So 1 and 3 are true. So why don't we hit up Delta Math real quick. Let me go back to that screen for you. Okay, so we want 1 and 3. That looks like this one here. Submit answer. Ah, yeah, that's how we roll. That's how we roll. Okay, I'm gonna go back now. Let's do this next type of problem. So the level 1. What you'll notice on the level 1s is that the variable, I think they're all positive. I think that's what makes them a level 1. In fact, that's a +6 and not a takeaway 6. But let's see. All right, so there's two things. First, we have to solve it, and second, I have to show you how to do this number line because it's a little janky, but it's still pretty good. All right, so let's stop share. Well, let me write the problem down. What we got here? -7 plus 6x is greater than or equal to -19. All right, let's go get this thing. So we want to isolate x in this case, just like we do pretty much anytime we're solving equations. So I'm multiplying it by 6, and then I'm going to add -7. So what I need to do is I need to take away the -7. So I'm going to take away a negative by adding, right? Because I got to take away -7. So I'm going to add 7. I'm going to add 7 to both sides. And that gets me 6 times x is greater than or equal to negative blah, 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 12. You never have to flip this inequality when you are adding or subtracting. Okay, so we're not going to flip the inequality. Now what I'll do is I got to get x by itself. So let me divide by 6, +6. And so we get x is greater than or equal to -2. That's the solution. We never flip the inequality when you multiply or divide by a positive number. Okay, so we're only going to flip this when we multiply or divide by a negative number. And then really, you could think about it just as multiplication, because to divide by 6 is to multiply by 1/6. So really, anytime you multiply by a negative, you're going to flip the inequality, and when you multiply by a positive, you won't. And at the very end of the video, we'll talk more about why that is. Okay, so usually we tend to graph these. So you put the boundary between your right answers and your wrong answers. -2 is the boundary. All the right answers are bigger than -2, so you have an arrow going that direction. And because it says greater than or equal to -2, we fill in the dot, which implies that -2 is a proper solution. Okay, so let's jump over to Delta Math and see how do we tell Delta Math that this is the solution. Let's see. Screen share. Let's go back to here. Okay, so it starts with the inequality. All right, so I'm going to go with, I'm going to type x. I'm going to click greater than or equal to -2. So that one's a little funky. What I'm going to try to do is I'm going to click and I'm holding it. I'm clicking and holding, and then I'm dragging this direction all the way to the end. So you click and hold, and then you drag. And that should work. Cash money, people. There it is, cash money. All right, let's do the one more example. Let's put the level 2 problems this time. And you can see, you've got the subtraction. So this one, we're going to end up flipping the inequality. Let me write the problem and then we'll do the problem. So what do we got here? 8 minus 3x is less than or equal to -1. All right. Very beautiful. Very, very beautiful. Let's solve this problem here. Again, we're going to try to isolate the variable. So really, I'm taking x, I'm multiplying it by -3 or -3, and then adding 8, because this is a positive 8. So first thing we got to do is we got to get rid of this positive 8. So I'm going to do that by a subtraction. So let's go -8. Okay, and I'll do that to both sides. So I get -3x is less than or equal to, because you're never going to flip the inequality when you add or subtract. All right? Okay, so I have -1, and I'm going to take away 8. Take away 8. So anytime you take away positivity, you're going to get more negative. So we should anticipate it being more negative. Now we got to divide, so we can get x all by itself. So I'm going to divide by -3. And we get x is greater than or equal to 3. Notice here that I flipped the inequality, because you always flip the inequality if you're going to multiply or divide by a negative number. So now we want to graph it. So we're going to put our boundary here. The boundary is 3. The numbers, sometimes you can put 0 if that's helpful. So the numbers bigger than 3 are going to be to the right. So I'm going to put a little arrow to the right. And then lastly, I'm going to fill in, because it doesn't say greater than, it says greater than or equal to. That's what the little line under there means. All right, so that's cash money. Feeling pretty good. Good enough to pause for a sip of tea. That's good tea. It's good tea. All right, I hope you weren't in a hurry. I feel like this isn't really the time to be in a hurry. I'm personally not really in a hurry these days. In fact, I'm sleeping in. It's like I don't have an alarm clock this morning. That's this whole distance learning. I don't set an alarm. When I wake up, that's when I wake up. All right. So what do we got? Inequality. I gotta say x is greater than or equal to 3. So I'm gonna go x is greater than or equal to 3. I gotta do the graph. So remember, the graph, click and hold. Click and hold. Okay, so what I'm going to do is I'm going to go to the 3. I'm going to click and hold and then drag. Click, hold, drag. There we go. That should work. Come on. Hey, there it is. All right. Ain't that something special? Ain't that something special? All right. Well, I think that's probably about it for this video. I'll just remind you of a few things. Like if you write something that you know is true, like say you know that that's true, you don't have to remember the rules about flipping the inequality around. You can just kind of do it and see what happens. And by that I mean, we know that 10 is bigger than 2. Well, if you multiply both of them by a positive number, like say you multiply this by 2 and this by 2, you get 20 and 4. And 20 is actually still bigger than 4. So when you multiply by a positive, you don't need to flip the inequality because it's still true. But if we were to multiply this by a negative number, this would become -4, and that would become -20, and now it's actually not true because -4 is greater than -20. So a lot of times what you can do is you can just try it and see, do I have to flip the inequality or not? That's another way of doing it. All right, well, I don't want to belabor the point anymore. Good luck. You got my office hours, so come on down to the office hours and we can do more of these problems. I hope you're well. I hope you're taking care of yourself, and be kind to each other out there.